Okay, I've got to do a Kruskal-Wallis test. It's a Kruskal-Wallis test because now I have 3 independent samples. We've seen the data from book A and book B, but now we're adding book C to the mix, so we'll see if that makes a difference. So, I've got this random sample, that's nice, of 19 students. I've got 3 different sample sizes, that's not a problem. It just says use a distribution free test, but Kruskal-Wallis is very easy to spot because it's the only one that applies when you've got more than 2 independent samples. Okay, I've given a significance level, and the claim is that students tend to score the same on average whichever book they studied from. So with hypotheses, this is a bit like Mann-Whitney. So H0 is that their samples come from identical distributions, okay? With H1, now for Mann-Whitney we had to worry about 1- and 2-tailed tests. For Kruskal-Wallis, the H1 will always be that essentially there is some difference, and that difference will always be, we're going to be interested in a difference on average. So we're saying there's some difference in the averages of the populations, okay? By which we mean they're not all the same. Could be that a couple of them are the same, but one is different. That would count as a difference in the averages. So I've got my hypothesis set up. I don't have a 1- or 2-tailed decision. We're going to be using a chi-squared statistic. We always do for Kruskal-Wallis. That only ever we're interested in the high values of that one. Okay, so step 2, I've now got to calculate my test statistic. So in my formula book, I have got page 14. Here we go. Now, Kruskal-Wallis does not get its own page in the formula book because it tells us here we're going to be using a chi-squared table to get the critical value. So it's page 14 you need to find your way to because you probably will have to look up this formula rather than memorizing it. So we need to work that out, and the things that we need to put into this are the values of TI, where TI is the sum of the ranks of a sample, NI. So I need the total of the ranks and the size of those samples for which I've worked out those totals, and then I need to put them into this formula. So let's go back and do that. So I'm going to need the total of the ranks for A, for B, and for C. Well, I haven't even done the ranking yet, so let's do that now. So the lowest rank is going to be for book B with this 21. The next lowest value is C with this 28. This is common for them to put the values in order to make the ranking easy. So here are my rankings. I don't know if you can read those. I've had to write quite small. I had a few tied ranks. I've got 2 4.5s, tie for 4th and 5th place. I've got 2 11.5s, and I've got 2 13.5s. So now my next job is to work out that TA, that TB, and that TC. So I've got to total the ranks. So I've got to do for book A, I've got to do 4.5 plus 9 plus 10 plus 11.5 plus 13.5 plus 15 plus 16 plus 18, and that total is, according to my calculator, equal to 97.5. And the totals for row B and row C of the ranks are 35 and 57.5. Okay, so you have to be really careful not to make any trivial slip-ups there. I think these values are correct. And I need the N value that goes within each one. So how many were there for book A? So 1, 2, 3, 4, 5, 6, 7, 8. So NA is 8, and NB is 6, and NC is 5. So those are the things that I need to shove into that formula from the formula book. So here we go. Here's our H formula. H equals 12 over n plus 1 times the sum of the TI squareds over the NI minus 3 brackets n plus 1. So I've copied that successfully. I've just got to apply it with my particular data. And of course I need a value for capital N. Well, capital N is the total number of data items altogether. It's the sum of these, which is 19. It told me there were 19 students at the beginning of the question. They do add up to 19. That's reassuring. So getting the formula where I can see it, I can now put stuff in. So I'm going to do this bit first. So I'm going to do the TI value squared, so that's the 97.5 squared divided by NI for that one is 8, plus 35 squared over its N value is 6, plus 57.5 squared over its value is 5. So I'm going to work that out first. Then I'm going to multiply it by 12 over n times n minus 1, and I'm going to take away this 3 lots of n plus 1 at the end. So doing the squared totals over the n values, that part of the calculation gives me 2053.6 0.698. So I need to do 12 over n times n minus 1, n plus 1, so that's 19 times 20. I need to multiply by that 2053.698, and I need to take away 3 lots of n plus 1. N is 19, so that's 3 lots of 20. So I'm going to do this calculation next. So there it is, press equals, and we get as our final answer 4.854. Okay, and that is my test statistic. So that was all step 2. Step 3 is finding my critical value. Now, my critical value for the Kruskal-Wallis is it's another application of the chi-squared distribution. So I need a critical value of chi-squared, but I need a number of degrees of freedom to look up in the chi-squared table. So the degrees of freedom for Kruskal-Wallis is I count up not the total number of data items, I just count how many groups I've got. So I've got 3 groups, and I take 1 away from that, and that gives me my degrees of freedom. So in this particular case, the number of degrees of freedom is 3 minus 1, which is 2. And that will be the commonest value you use, because most questions, very commonly, they do have 3 groups, as we did here. So I need my significance level as well. I've got my degrees of freedom. My significance level is 5%. Remember, with chi-squared, we don't have to worry about one-tailed or two-tailed, because we always use this right-hand side with the high p-values. So for a 5% significance level, I have to remember to use the 0.95 column. My degrees of freedom is 2, so the value that I need from the table is this one here, 5.991. So my comparison is going to be between my test statistic of 4.854 and 5.991. This is clearly less than, and that means this is not significant. So this is not significant at the 5% level. So therefore we are going to be accepting H0, and our conclusion is going to be that there is no evidence, or I should say at the 5% level, of any differences in the median scores of students studying from books A, B and C. So you always come back to the context in your conclusion, and that does for that particular test.